I continue to work by talking about the specified condition analysis. In order to perform the specified condition analysis, you must first select the specified condition option and determine the analysis type. You can specify the analysis type by selecting the specified condition option. Or in the analysis tab, you can select the analysis you want to perform in the Set Analysis Type tab. The specified condition analysis, as the name suggests, calculates the condition you specify. In other words, it makes hydrostatic calculations at the draft value you specify or the displacement value you specify. Therefore, loading conditions, intact condition or damage condition are independent of this analysis. Because in this analysis, we determine the draft and displacement values ourselves. Therefore, it is a type of analysis independent of all loading conditions. This means that any offloads, tanks or extra weights that we will add in the load case window in the future will not be included in this calculation. Because in this specified condition analysis, we determine the condition ourselves. In the load case section, none of the loading conditions we added to the boat have anything to do with this analysis. Having said that, I want to mention the Analysis tab. There will be differences in the Analysis tab according to the analysis type you have determined. So, the comments you can use will change. Whichever analysis you are doing to do, you must refill the data in the Analysis tab according to each analysis you want to do. In other words, you should re-enter all the values according to that analysis, whichever analysis you are doing. For example, we cannot enter the heel value for a specified condition. But suppose we enter the heel value for a different analysis. Then you wanted to do a different analysis. You must re-enter the heel value when you change the analysis. For example, in the first stage, I entered the heel value in the hydrostatic analysis. In the second step, I choose the Kn analysis. I have to re-enter the heel value. For both analyses, you need to re-enter the heel value. Like heel, we need to re-enter all the values. As a result, you need to enter the analysis menu, whichever analysis you selected, and determine the values for the analysis you selected. Let's continue by examining the Analysis tab in the Specified Condition analysis. I'm leaving the Specified Conditions comment for last. I want to talk about the comments at the bottom. Density is the part of Max Surface Stability module where you work and determine the densities of liquids. I click the comment. The most important thing here is seawater. That is the density of seawater. You can see that it's already written in bold color compared to the other text. The analysis is done according to the liquid density determined here. Since we analyze in the seawater, our density is 1.025 kg divided cubic meter. But if we are calculating in fresh water, we would have to change to this 1 kg divided cubic meter. Be sure to check the density section when performing each analysis. Because the density of water is wrong, all your calculations will be wrong. I would also like to say, classification societies have determined the density of water 1.025 for boats to operate in the sea. The density of water may differ from season to season, but this situation is dependent of us. We need to make the calculation as 1.025 kg. I exit here using the cancel option. I open the Analysis tab again. I choose the Wavefrom command. By using the Wavefrom command, you can analyze in fixed water as well as in choppy waters. When the flat option is selected, you only calculate for fixed water. All the analysis you make will be done in flat water. However, if you select the sinusoidal and trapezoidal wave options from the bottom, you can calculate using the wave type you have chosen. I have a wave type before me right now. By editing this wave type, I can get analysis results in the wave condition I want. In other words, you determine in which wave type the analysis will be made. When you select sinusoidal trapezoidal options, the boxes on the right will become active so you can play with the shape of the wave. Wavelength refers to the length of the wave in the longitudinal position. Since the distance between the f-peak and 4-peak is 64 meters, this place is automatically determined as 64 meters. If I make this value 74 meters, the wave will stretch a little longer and will be 74 meters. Let's do 74. The preview will be shown when we do. It was set at 74 meters. I change the value from 74 to 64 again. When I make 64 meters, keep your eyes on the wave height. I'm doing 64 meters. When I made 64 meters, wave height was calculated automatically. In other words, when the length of the wave changes, the wave height is calculated automatically so that height of the wave can change proportionally. So, when you change this value also changes automatically. Of course, you can change this value again. The phase offset option at the bottom is the option to carry the wave crest. So, you enter values between 0 and 1. If we write 0.5 here, it will be positioned so that the wave crest is in the middle of the both. You can also specify the wave crest and wave through using phase offset option. So if you write 0.6 here, it will shift a little to the stern. If you type 0.4, it will shift to the bow a little bit. You can specify this in the phase offset section. Toroidal is also a different type of wave. When you click it, you change the wave type. I'm out of here by clicking the OK button. Then I enter the Analysis tab. I'll talk about hog and seg commands. Before I mention it, I want to show. I want to open water plane, namely DVL. I open the DVL, the wave type will be shown here. We can also see this wave in perspective view. Now the calculations will made according to the wave structure I added. Which wave type you have chosen, calculations are made according to this wave type. Now I'm in the Analysis tab again and select the hog and seg command. This is the part where you can determine the segging and hogging values of the wave. We can see it more clearly in the profile view. I open the profile view, then Analysis and hog and seg. You have to activate the Apply Hog or Seg Value option. In this way, we can edit the segging and hogging values. When we click, we must enter plus for segging and minus for hogging. These values are taken from the center line. For example, I enter a 2 meter segging value and click OK. You can see the change the waveform in of the stern and the bow side. You can edit the structure of your waveform in more detail by using the hog and seg command. Or let's open the Analysis and hog and seg command again. Let's write -2 here. This time a waveform will be generated for the hogging. Okay, this time there was a hocking. Now I come back to the Analysis tab. I come to the hog and seg command. There is a center image ship option under the center of deflection heading. If you want the reference point of the value you have determined to be midship of the boat, you must tick the box. Or you can set the reference point yourself. From which point you wanted this process to be done, you can select the option below and enter the value you want. I will not use the wavefrom or hog and seg commands when calculating. These are not needed in the stability booklets for yachts and many types of ships. In addition, they are not the values requested by the classification societies in the stability booklet. That's why I'll only add fixed water analysis to the stability booklet. But if you want to do it, all you have to do is specify the waveform. After determining, there is no difference in the process. You can do all analysis as in fixed water. When you do, your calculations is done according to the waveform. I turned off hog and seg by unchecking the box. Then I open Analysis and Waveform command. Since I want to analyze in fixed water, I select the flat option and press the OK button. I open the Analysis tab again. I have already mentioned the criteria comment. That's why I won't mention it again in this lesson. It would be good for you to check the criteria comment before each analysis. At the bottom, there is the command Recalculate Hull Sections. When you click the command, you can recalculate the sections in the pop-up window. This is the window that appears when opening the Stability module. If you want to change the number of sections, or if you want to include thicknesses, or if you want to change the quality, you use this. You don't need to exit the program and enter it again. Using this command, you can do these operations without closing the program. Cancel. I come back to the Analysis tab. Snap Margin Line or Selected Key Points to Hull option. When you enter the longitudinal position and vertical position values of the margin line, you can automatically calculate the offset value by clicking this command. Let's open the margin line window. If you enter longitudinal and height by yourself, it will automatically calculate the offset value to overlap the hull when you click the command. This is the purpose of the command. I'm back to the profile view. I said that you can specify the analysis you want to do from the Set Analysis Type section. At the bottom, there is the Start Specified Condition Analysis option. You use this command to start analysis. In other words, you can start the analysis by pressing the Start command for each different calculation. There are Resume and Stop options at the bottom. If you click Stop while the analysis is in progress, the analysis will be stopped. If you press Resume, the analysis continues. That is what these commands are for. At the bottom, there is Start Batch Analysis command. It is a command that allows you to do all of them simultaneously rather than performing different analyses one by one. You click the command, you enter the required values, and then when you start the analysis, it will do all the analysis for you one by one. It will perform all the analysis in the Stability module one by one. That is the purpose of the command. After talking about all types of analysis, I will talk about batch analysis. But for now, I won't talk about it. I continue with the Specified Condition command. I click on the Specified Condition command. Specified Condition Analysis is the command that will allow you to obtain hydrostatic calculations in the conditions you specify. In the heel option, we enter the heel value of the boat in the port starboard direction. So if you want the boat to heel, you should add the value here. There is one more important thing I want to say about the Stability module. Be sure to take note of this. Inside the Stability module, starboard is always indicated with positive values and port always with the negative values. So if we are talking about the starboard, there is a positive value. If we are talking about the scaffolding, there is a negative value. Inside the Stability module, this is always the case. The Fixed Heel option allows you to calculate heel values you specify. For example, if I write 10, it will give the results under the condition that the boat is heeling 10 degrees to starboard. If I type 50, it will give results under the conditions that the boat is heeled 50 degrees to starboard. Or if I type minus 30, it will give the results under the condition that the boat is heeled 30 degrees to port. If it says fix somewhere, you are setting a fixed value yourself. If you select the free to hail at the bottom, you must enter the center of gravity. Already when I click the command, this place was selected automatically. If free heel is mentioned, you must enter the TCG value, that is the location of the center of gravity in the direction of port starboard. If you do the analysis in this way, the heel value will be calculated according to the locations of the center of gravity. That is, when the TCG value is 0, there is no heel. But the TCG value, I mean the transverse position of the center of gravity, can be either a negative or positive value. You will find out how much heel situation makes the boat in the port or starboard direction. Let's talk about the trim option. Fixed trim will do calculations when the boat is trimming at the trim value you specify, such as stern trim or bow trim. If we write 0.5, it is enter a positive value, the boat will trim in the stern. If we enter a negative value, the boat will trim in the bow direction. In other words, we determine the trim value as the positive stern or negative 4. If we write the 0.5 meters, we have to determine a condition in which the boat will trim in the stern. It says fixed here. Since it says fixed, we have to set the value ourselves. But if we select the free to trim option, the trim value is now calculated according to the locations of the center of weight. For example, the LCG value may be near to stern or bow of the boat. In this case, according to the position of the center of weight, you can calculate how much trim the boat will do. If you check the free to trim option, you must enter the LCG and VCG values. I will define the values of LCG, TCG and VCG. LCG is location of the center of weight in the stern bow direction. TCG is the location of the center of weight in the direction port starboard. VCG is the center line and the location of the center of weight in the direction of the deck. So you can think of it as the coordinates of the center of weight in 3 dimensions. First, let's start working with the fixed option. Then we can continue to work with free. After determining the heel and trim values, you must determine the values under the immersion heading on the right. That is, we must enter the displacement or draft value of the boat. If you enter the draft value, you don't need to enter the displacement value, because the displacement value is calculated automatically according to the draft value you specify. Or if you enter a displacement value, you don't need to enter a draft value, because the draft value is calculated automatically according to the displacement value you enter. So even if the stability module allows you to enter both draft or displacement values, you must only enter a value for one. Either at the displacement value only, or just the draft value. For now, let's set the draft value for our boat. We had determined the maximum draft value as 4 meters. Let's write 4 meters here. When I type 4 here, when the boat trims 0.5 meters aft, the aft draft and fore draft values will be calculated automatically. Or let's choose the draft option. If you type a value for aft or fore draft, the trim value will change automatically. Because according to the trim value of the boat, the aft and fore draft values must also change automatically. Let's start with fixed water first. I'll talk about the trim situation later. We added draft amidship fixed trim values of 4 meters and 0.5 meters. I close this window using the OK button. Then from the Analysis tab, I select the Start Specified Condition Analysis option. When I select it, the analysis will start automatically, or here is the shortcut. By clicking the button, I can start the analysis. We can see the boat doing trim towards the aft. As we can see visually, we can view the calculations in the Results window section. I come to the Results window. Draft and hydrostatic values in the midship of the boat were calculated using the conditions I determined. Let's go back to the profile view. Now let's define a different situation. I select the Specified Conditions option. Currently I will only use fixed trim values. Because in order to use free to heel or free to trim options, you need to know the locations of the center of gravity. By the way, in the preliminary design phase, you can learn the required center of gravity values for the boat to be in equilibrium with the help of this section, but I will not use it for this purpose for now. For now, I'll just use the fixed options. Let's set the fixed heel value to 15. Let's the boat heel 15 degrees to starboard. Now let's click OK again. Let's restart the analysis. Condition results will be displayed when the boat is heeled 15 degrees to starboard. You can also see this in perspective view. The boat is now heeled 15 degrees to starboard. And the calculations will be shown to us when the boat heels 15 to starboard. Let's get to the profile view. Let's use the Analysis and Specified Conditions comment again. Let's enter the displacement value this time, not the draft. Let's enter a displacement value of 1700 tons. Then I click OK and start the analysis. In the Results window section, the draft value was calculated according to the displacement value we determined. The displacement value was calculated according to the draft value we entered in our previous analysis. This is the reason why we don't enter both values at the same time. That is, we only enter a value for one. According to the value we entered, the other value is calculated. From the Analysis tab again, let's click on the Specified Conditions command. Let's enter the draft values for draft forward and draft aft. Let the draft be 4 meters at the fork. Let the draft be 2 meters at the aft. Currently, the fixed trim value is calculated automatically. The draft values I determined correspond to the trim value of -2 meters. I press OK. I come to the profile view and started the analysis. Now it gave this error. Because it was writing the analysis, I made in the Word file in the background. So, I can show you this. When each analysis I did was completed, it exported the results to a Word file. I'll show you how to do this in the Results window lessons. While analysis, you can have the results automatically transferred to a Word table. This will help you in terms of time. But I will explain this in the Results window lesson. Calculation was made in the condition we determined. We entered the draft values for the fore and aft. Our hydrostatic values were calculated according to this condition. Or we can do the analysis again by changing the heel value. Let's get to the perspective view. The boat is now heeled 15 degrees to starboard. It will look a little clearer if we look from the stern. I'm adjusting the view. Now let's use the Specified Conditions option again. Then let's change the value from 15 to -30. I'm typing -30. And I click OK. Then I start the analysis. The results will be displayed when the boat is heeled -30 degrees to port. At the same time, we have obtained the visual of this condition. That is for the Specified Condition analysis. That's it for this lesson. See you in the next lesson.